I like to think about it as a path that opens up. For example, let's take a series circuit. A series circuit could be where you have one path that you've got to walk around to get back to the beginning again. But with a parallel circuit, it's like you're walking on a path that then splits into two separate paths. Then you have to choose which path to take until it leads you back to the same path again. If we have a coil of wire and run a current through that coil of wire, we have produced a solenoid. And if we remember, a solenoid is a device that produces a magnetic field. And so what we are essentially doing here is by driving a current through this coil of wire on the primary side, is going to produce a magnetic field that is then being pushed through this iron core. Now, if we remember our magnetic materials, iron is one of them. It can be easily magnetized. And if it can be easily magnetized, then iron is a magnetic field conductor. Now, we've got to be careful with this and be absolutely sure what we mean by that. Transformers are made of iron, which... What this allows us to do is it allows us to calculate our thinking distance. But what exactly is thinking distance, and what is braking distance? Let's take a look at these two first. Thinking distance is the distance that is travelled by a vehicle before the brakes are applied. So let's focus our attention on this middle diagram here. Here we have a car that is moving with a velocity. So you can see I've also drawn this diagram as a graph here, where the velocity starts at its highest. So the vehicle is moving at a constant velocity. Now, first of all, what happens is the traffic light turns red. And there is a brief moment for that driver where their brain is processing.